Hello everyone, in this video I will be discussing how to select a development methodology. The learning objectives for this video are: first, students should be able to describe various approaches to the system's development lifecycle that can be used to structure a development project. Secondly, students should be able to explain how to select a project methodology based on project characteristics. First, let's define what is meant by methodology. A methodology is a formalized approach to implementing the system's development lifecycle. It's a series of steps to perform and deliverables to produce. There are several different sources for choosing a methodology. First, many methodologies are internally developed by organizations, but methodologies can also come from consulting firms, software vendors, or even government agencies. The most traditional type of development methodology is waterfall. Waterfall is based upon the system's development lifecycle, and it assumes a project phase is complete before moving on to the next phase. And the goal of waterfall development is doing each phase thoroughly before moving forward, which will ensure correct and high-quality outcomes. So waterfall development looks like this. You start with your planning phase, and once all of the planning is done, you move on to analysis, and then design, and then finally implementation. The dashed lines on this diagram show that you can and probably should go back and refine and update some steps in previous phases. For example, going back to your feasibility analysis from the planning phase. However, most of the work must be done in each phase before you move on to the next. What are the strengths and weaknesses of the waterfall method? First, the strengths are that the system requirements are identified long before the construction of the system begins. Requirements are frozen as the project proceeds, so no moving targets are allowed. Obviously, there are some weaknesses as well. First, you must wait a long time before there is visible evidence of the new system, and it takes a long time from the start of the project until things are done. Now, while waterfall is the most traditional method, it's rare today to see an organization that uses only the strict waterfall methodology across all of its projects. There are some variations of the traditional waterfall development, such as the parallel development and the V model. Again, the goal here still is to complete each phase thoroughly before moving forward to ensure that you have correct and high-quality outcomes. Here's what parallel development methodology looks like. Again, you start with your planning phase and do all of your planning before you move on to your analysis phase. Once your analysis is full and complete, then you move on to a general design of your system. At that point, you break up your project into several sub-projects. And for each sub-project, you simultaneously work on designing and implementing those sub-projects. Then at the end, you bring all of your sub-projects together into one big system implementation. What are the strengths and weaknesses of the parallel methodology? Well, in comparison to the traditional waterfall, it reduces the overall project time because you are able to work on multiple sub-projects at once. It also reduces the need for rework. With a shorter time frame, you have less chance of the requirements changing from beginning to end. The weaknesses of the parallel methodology are, first, that you have to create the sub-projects, which requires some careful design decisions up front. It's hard to know exactly how to split up your project into different sub-projects. And it's also hard at the end to integrate sub-projects if they are complex and difficult. Let's take a look at the V model development methodology. Like the other waterfall methods, you start with planning, then you move to analysis, and then design, and then implementation. However, in the V model, while you are doing analysis and design, you make careful plans for how you will do testing of your system once you get to the implementation phase. In this way, you are thinking more about the ultimate coding and testing of your system while you are still in the earlier phases of development. So then once you get to implementation, you spend a lot of time focusing on testing based on the tests that you've developed during your analysis and design phases. The strengths of the V model are that it's simple and straightforward. Again, you're just moving from planning to analysis to design to implementation. But you also have improved quality because you emphasize testing even while you're still in the analysis and design phases. It also includes quality assurance expertise early in the project to ensure that you have a high quality system. The The weaknesses of the V model, like the traditional waterfall method, are that it's rigid and it's difficult to use in a dynamic business environment when things are going to be changing or you might have new requirements coming up. So to summarize, the three waterfall type methods are the traditional waterfall, parallel, and the V model. Let's talk about a different type of methodology, the rapid application development. Rapid application development incorporates some special techniques and tools in order to overcome the weakness of the waterfall methods that take a long time. First, there's CASE tools. CASE stands for Computer-Aided Software Engineering. These are types of software packages that automate some or all of the development process. These can be tools such as Visible Analyst. CASE tools take diagrams and other sources that you use during the analysis phase and turn them into design elements. They can also take design elements and turn them into coding elements. For example, using the design that you create in a CASE tool, some CASE tools will take that design and output a set of code or generic code that can be used in the implementation phase. Another special tool that helps with rapid application development is JAD sessions, or Joint Application Design. These are sessions where users and analysts and designers come together in one meeting to discuss the requirements and the design of the system. This is opposed to the traditional method where the system analyst simply observes or interviews users about their needs. In JAD sessions, the users come in, sit down with the analysts and designers, and help in the actual analysis and design process. Another tool that has helped with rapid application development is visual programming languages and visual editors of traditional programming languages. These are tools that allow you to program visually, which brings the design and implementation phases closer together. If you are interested in learning more about visual programming languages, I recommend the Wikipedia page titled Visual Programming Language. Visual editors of traditional programming languages are software packages like Microsoft Visual Studio or the open source NetBeans or Eclipse. All of these things help developers to get some portion of the system developed more quickly and in the user's hands. Here are three rapid application development approaches. Iterative development involves a series of versions developed sequentially. System prototyping involves creating a prototype or model of the system and growing it into the final system. And throwaway prototyping is like system prototyping, but the prototype alternative designs are done in a more experimental way and are discarded before the actual system is built. Here's a diagram that's helpful in visualizing what iterative development looks like. In iterative development, you start with your planning phase, and then you do some general analysis, and then at that point you start working on an initial version of your system. That doesn't have to be perfect, but it's as close as possible. And you move through the phases as you would in a waterfall method, with the analysis, design, and implementation. After the first system is implemented, there's a set of feedback and an opportunity to go back and analyze, design, and implement a second version of the system, and so forth for as many versions as you need until the system is ready. The strengths of the iterative development methodology are that users get to use a system more quickly. Users can also identify additional leads for later versions based on their actual experience with the first version of the system, whereas in the waterfall method, users have to use the only version that was developed. The weaknesses of iterative development are that users are faced with using an incomplete system for a time. When version 1 is done, users will be using a system that is not as complete as they would like it to be. And users must also be patient and wait for the fully functional system to be ready. Let's take a look at system prototyping development methodology. In this methodology, the planning is done all at the beginning, and then there is a series of analysis, design, and implementation phases that go iteratively while the system prototype is developed. The difference between system prototyping and iterative development is that the system prototype is never fully functioning. In iterative development, you have a full version of the system at the end of your first analysis, design, and implementation, and then improvements are made to that system. With a prototype, you go piece by piece. So in the first prototype, you might only have the most critical elements of the system ready for the users. It does not replace the old system. it's simply a prototype. But users still have the opportunity to get feedback before more analysis, design, and implementation is done. And then finally, the prototype is converted in the final implementation phase to the full system. The strengths of system prototyping are that users get to work with a prototype very quickly, and the feedback cycles let users identify changes and refine real requirements. However, there are some weaknesses, as with every methodology. Superficial analysis may cause problems, and initial design decisions may be poor, and there might be overlooked features that are hard to add later. Here's what throwaway prototyping development looks like. It's similar to system prototyping, except that the prototype is more experimental in nature and not usable. It might be a series of screens that users are able to play around with but don't have any working functionality. There is an iterative working of the analysis, design, and implementation phases to improve the prototype, and when the prototype is at its best, then the analyst moves forward to the full design and implementation of the system. The strengths of throwaway prototyping are that uncertainty is minimized, and important issues are understood before the final system is even built. The weaknesses is that it might take longer compared to system prototyping because the actual system isn't being developed during the iterative process. So to summarize, in rapid application development we have iterative, which goes from a full version to improved version. We have the system prototyping, where the system is built one piece at a time. And we have the throwaway prototyping, where a prototype is built one piece at a time before the full system is begun. The final grouping of methodologies is agile development. Agile development refers to carrying out the SDLC in a series of several iterations of full mini SDLCs over a period of time. So you do planning, analysis, design, and implementation over and over and over until you're satisfied that the system is at a good place. Agile development was developed to overcome limitations of the traditional and even the RAD methodologies. So formal modeling and documentation are eliminated in favor of face-to-face communication with the user. And the goal of Agile development is early customer satisfaction, the priority of allowing changing requirements, and the priority of good communication with the user over formal and slow documentation. Here's an example of what Agile development methodologies might look like. The planning box is in dashed lines because little formal planning actually happens in Agile development, other than the system request or proposal and designating a project lead. In Agile, you just jump in and start in very short phases of analysis, design, and implementation. These phases can even be as little as 2 to 4 weeks, so it's very iterative in nature. The strengths of Agile development are that you get very fast delivery of results, and it works well in projects that have undefined or changing requirements. However, at the same time, it requires discipline and significant user involvement. There's also an initial high learning curve involved in Agile methodologies, and it works best in smaller projects. More coordination is required because the analysts and the designers and the users all have to come together in every iteration. In some types of Agile methodology, there's a team that is put together of analysts, design, and users, and they meet every 2 to 4 weeks. So users are heavily involved, which can be a pro, but it can also be a con because of the increased coordination. Here's a summary of what types of systems work well with the different development methodologies. As you saw, each of the development methodologies has strengths and weaknesses. Now, you don't have to memorize this whole table, but I would recommend studying it for a while and trying to best understand which types of project each methodology is suited for. Many organizations use different types of development methodologies, and it just depends on the project and what the needs are. So for example, projects that have unclear user requirements work really well with Agile or with prototyping methodologies, where you have that iterative process where users can give feedback. Of course, the waterfall methodologies are very poor in those situations because you have to do all of the planning and analysis ahead of time. Similarly, with unfamiliar technology, throwaway prototyping is very good because the users have the opportunity to work with the technology. Waterfall techniques are not as good because users do not have a chance to work with the technology, and even agile development is not good in this case because users have to be heavily involved and have quick turnaround with each iteration of the system. Complex projects are very well suited to throwaway prototyping and also to the traditional waterfall method because you can have that time to do thorough planning and analysis before you jump in and do any design and coding. If reliability is your main goal, everyone wants reliable systems, but if reliability is the main goal, such as for health systems, military systems, then a methodology like the V model or throwaway prototyping are the best because there is a focus on user feedback and on testing throughout the entire process. If you have a short time schedule, agile development and iterative and system prototyping are good because users can start using the new system right away, even if it will be refined later. Finally, if you want to have a good grasp on how long the project is going to take, it's easy to tell in the iterative and system prototyping methodologies. Now that you know about the different development methodologies, take a minute to reflect. If you've worked with systems development before, which type of methodology did your organization use? What do you think were some of the benefits and drawbacks of using that methodology, specifically for your organization? In summary, we've described some various approaches to the SDLC and explained how to select which one would work best depending on the project.